Okay, so the first lesson in Unit 3, we'll begin our study of inequalities, are linear inequalities and absolute value inequalities. This should serve as a review to you, okay? So please take your time to go through the examples. I would suggest pause the video, work it out, and then make sure that your answer is the same. There's only a few things that I have to continue to point out for you. Okay, so solve and graph each. Okay, linear inequalities, linear. We got to think equations of lines, degree of 1. All right, get x alone. I'm just simply going to add 8 to each side. X is less than -4. So if I graph this on a number line, okay, here I am at -4. Open circle because it cannot equal, and I graph everything to the left of that. So let's remind ourselves, solutions to equations, right? When I have an equal sign, I get one value, right? X equals 4. That would be it. Remember, for inequalities, we get entire ranges of solutions. Okay, so any number smaller than -4 would satisfy this inequality. 1/2 y is greater than -2. All right, I'm going to multiply both sides by 2 to get y alone. Y is greater than -4. So now on my number line, I still have an open circle. And now I shade everything to the right. So any number bigger than -4 would make that inequality true. Okay, so here's number 1. So recall, when you multiply or divide an inequality by a negative, that's where we got something going on. Okay, so I'll rewrite this. -3/10 a is greater than or equal to 9. So to solve for a, I'm going to multiply by -10/3 on both sides. When you multiply or divide an inequality by a negative, you must change the direction of the inequality. So notice here, on the right-hand side of these equations were negative numbers, but it doesn't matter what the answer is, it's all about the operation. Okay, so when I multiply or divide an inequality by a negative, I have to change the direction of the inequality. All right, so this gives me -3. So a is less than or equal to -30. Your graphs, I just need to see the number, open circle or closed circle, and the direction that you're shading. Okay, these do not need to be fancy graphs. All right, so solving for D, first I'm going to subtract 1. All right, again, even though I'm subtracting, I don't change the direction. But now when I divide both sides by -2, now I get D is greater than or equal to -3. Okay, -3, open circle to the right. All right, now I'm going to add 1. -7x is bigger than 14. Divide by -7. So now I divide it by a negative. X is less than -2. I change that direction. Open circle at -2, and I shade everything to the left. All right, please don't let fractions confuse you, okay? If this were a equation, okay, my stylus is going a little crazy. If I set this up as a proportion, remember we cross multiply. Then I get rid of my denominator. Same deal here. So I'm going to cross multiply, and I don't have to worry about changing the direction of the sign because both of my denominators are positive. So I'm going to have 6 times 2x plus 3 is greater than 9 times x minus 1. Okay, distribute on both sides. I like to keep x on the left-hand side of the inequality. Okay, so I get 3x is greater than -27. So now when I divide by +3, I don't have to worry about changing the direction at all. -9, open circle, and I shade to the right. So what if I reverse the order? I'm going to add 9 and subtract 12x from both sides. So now I get 27 is bigger than negative 3x. Okay, so if I were going to do that, I'm going to divide by negative 3. I get negative 9 is less than x. Okay, so if I look at negative 9, it still gets an open circle. Negative 9 has to be smaller than every other value in the solution set. So it's still the same direction. Okay, these obviously have to be equivalent to each other, but you just have to think about what the inequality actually says. Now, if I wanted to switch x, my solution and my variable, again, I would have to change the direction. Okay, so again, these guys are equivalent to each other, and now I see the exact same solution from the first. So again, I just like to keep x on the left-hand side of the inequality, because then the direction of the inequality is always the same direction as my graph. All right, so this is literally chapter 2 of Algebra 1, when you first learned about inequalities, solutions to inequalities, and then absolute value. So remember that the absolute value, okay, the absolute value makes whatever's on the inside positive, but absolute value really represents distance. So you have to be careful. We know distance, it can be 0, but it's got to be non-negative, okay? So if I'm talking about absolute values can equal 0. They just can't equal a negative number. So when I go to solve this, remember you always had to set up two equations. So x can be 7 or x could be negative 7. Because if I take the absolute value of positive 7, it stays the same. Absolute value of negative 7 becomes positive 7 as well. So these are my two solutions. So if you have two absolute value equations to solve, then when we get into absolute value inequalities, you need two as well. Okay, let me see where I have this. So let me just go up a second here, okay? So absolute value equations, I have two answers, right? I keep what's inside the same. I set it equal to the positive and the negative of the answer. When you have an absolute value with a less than, this is, oops. Go back to this. This is a compound inequality, and it's an AND statement. Okay, so compound inequality so that combines two inequalities, and it uses the words and or. So a less than is always a compound inequality using the word and. A greater than is a compound inequality using the word or. So notice here that I literally have the word or, but notice on an and, I can bound what's inside my absolute value by the positive, that's keeping it the same, and the negative. So the direction of the inequality is super important when you're solving absolute value inequalities. So now let's go back to the examples. So I have absolute value of x is less than 7. So this is a less than, so this is an and statement. And to get rid of my absolute value, I have to, I bound x between the opposite of the answer and the positive of the answer. So I'm saying x is any number between negative 7 and positive 7. So when I go to graph that, I put open circles at both negative 7 and 7. And then I shade everything in between those boundaries. And I should have, let me go back to number 7. If I were to graph this, because this is an equation, it's just negative 7 or 7 could be answers. So they just get solid dots. All right, absolute value is greater than negative 7. We're going to approach this in two different ways. So this gets an or statement. I need you to think about this. So when it comes to absolute value, you have to think. Don't just become robotic about how you solve this. Absolute value is greater than -7. Well, what does the absolute value do? It always makes what's inside the absolute value bars a positive number. So if I just look at this statement, I have a positive number greater than -7. Isn't that always going to be true? So my solution here is all real numbers. Every single value of x I plug in there, no matter how big or how small, when I take the absolute value of it, it becomes positive. And a positive is always greater than a negative number. So if I were to graph this, it's literally the entire real number line. Okay? So again, think about these. So whenever you see an absolute value with a negative as on the other side of the equation or the inequality, just use what you know about absolute value to answer the question. All right, solve and graph each. So now I have an equation. So I like equations because we're more familiar with them. So I set what's inside the absolute value bars equal to +10. And then I set what's equal to the absolute value bars equal to -10. Not what I wanted to do. This is the one that everybody gets. This is the one that's easily forgotten. Okay? So just solving 2x equals 5, x equals 5/2. Notice that your steps are exactly the same. I subtract 5 and I divide by 2. I'm just subtracting from a different value. That's why you can't just tell me that the answers are plus or minus 5/2. You changing that equation, it's changing what I'm adding and subtracting. Okay, so these are one or the other will make that equation true. So I just get two closed dots, two closed circles. This is a less than, this is an and inequality. Okay, so when I solve, when I solve an and, I bound it between those two values. All right. So I get -10 is less than or equal to 2x plus 5, which is less than or equal to 10. Okay, I lose the absolute value bar as soon as I make it into this compound inequality. Subtract 5, but now be careful, you're subtracting 5. It's like I have 3 regions here that need those same steps. So I get -15 is less than or equal to 2x, which is less than or equal to 5. Now to get x alone, I'm going to divide by 2 on all those parts. So now notice the values for x are the same, -15/2 and 5/2. But now what's in the way we graph them, so when I read this, I'm saying x can be any number in between -15/2 and 5/2, and it would make that statement true. Okay, so your and, when we graph them, we have to think that we're going to be between two values. Okay, so we'll start class with these two examples as our warm-up. So you can try them in your notebooks if you like, but you don't have to submit their answers or anything. We'll do those together. Okay, thank you.